Okay, let's review conditional probability. Sorry, let me just pick a suitable color. So what we are interested to learn is conditional probability. Okay. So let's take a simple example. So what's the example? Let's take a class. So let's say that there is a class of strength 100. Okay, the class is divided into three groups. Like three groups of citizens are there. It's an international class. So there are Singaporeans, there are US citizens, and then there are, let's say, Japanese citizens. So Singaporeans, there are 10 of them, US there are 20, and Japanese, let's say there are 70. So that this makes 100. Let's say we further subdivide into males and females. Let's say there are 5 males and 5 females. US has let's say 2 males and 18 females, and Japan, let's say, has let's say 60 males and 10 females. Okay, so we can now draw a Venn diagram of this class. So let's do that. So to do that, let's first draw the entire class. So this is the class. Okay, so the class has citizens from three groups. So let's first draw the Singaporeans. So let's say these are the Singaporean group, and let's say this is US, right? So US is twice, yeah. So this is US. So this US region is twice as thick as Singaporean region, right? So this is Singapore. Sorry. So let's. So this is the first region is Singaporean region, this is last region is US, and the middle one is Japan. The ratios have been chosen so as to draw it to scale as much as possible. Okay, so in Singapore there are two types of people, like half the people are male and half are female, so we will draw a line in the middle. US has 18 females, so let's draw to indicate that. Right, so we will color the region of female in blue. So let's do that. So these are all Singaporean females, these are all US females, right? So there are 18 US female citizens, students, and there are 10 Japanese female students. So let's draw that. Okay. So 5 Singaporean female students, 10 Japanese students, and then 18 US students. Now here we can ask questions like this, right? We can ask, suppose a female student is picked at random. Now the question could be, what is the probability she is Singaporean, right? Now this has a very intuitive notation. So we are asking what's the probability of getting a Singaporean, but we are only looking at female students. So this notation given indicates that we are only looking at female students, right? So basically what you have to do is you have to look at what is the proportion of female students in the entire female students. So there are 5 Singaporeans who are female, and there are 5 Singaporeans who are female, then there are 10 Japanese female students, so let's write that, and then finally there are 18 US female students. So this number is 5/33. Now we can immediately see that since this is a ratio, we have a conditional probability is going to be a number between 0 and 1. Okay, so similarly we can also see what is the probability that you don't pick a Singaporean given that you pick a female student. So this is going to be how many non-Singaporeans female students are there, that is this, right? So this is going to be 1 minus 5 over 33, but if you observe, that is nothing but P of SG given F. So this is like the second law of conditional probability. And finally we can also ask questions like what is the probability that you pick a Singaporean, okay, or okay, let's say or a US student, okay, given that you are only picking female students. Now this is going to be, there are totally 33, so Singaporeans are 5 and US, how many are there? There are 18. So this number is going to be 23 over 33. So which is also equal to, so this is, sorry, this is not F but it's P SG given F plus P US given F. Okay, so since Singaporean, set of all Singaporeans and set of all US citizens are disjoint, right? So you cannot be a citizen of Singapore and US. I mean, it's sometimes true, but let's say this is you don't have such students, then this kind of third law of conditional probability holds. Now these three laws are like your usual laws of probability. What were the usual notation that you would have seen? So this, there is another way to compute this P of SG given F, is basically you look at this ratio. So what is this formula saying? You look at basically the class in total, and what is the chance that you pick a Singaporean and female. So what is that number? So there are 100 students, and what is the chance that you pick Singaporean female? That's 5 out of 100, right? So this number is 5 out of 100. And what's the chance that you pick a female student? There are totally 5 plus 18 plus 10, there are 33 females. So what's the chance that you pick a female student? That is 33 over 100. So this is also 5 over 33. So both the formulas give you the same thing. So which formula how do you use it? Do you write Venn diagram and do it, or do you use this formula? So that depends on the problem, and if the things are representable in Venn diagram, use Venn diagram, or otherwise try to use this formula. So I will give you a method to remember this formula. So if you are supposed to do this, P of this, so what you do is whatever comes on the other side of given, put it in the denominator, okay, and the numerator will be A intersection B. So this is the way in which you can memorize the formula, but the idea is already there. So let's try to recollect the idea. So basically you are having the universe of all the things. This is, let's say, A, this is B, so this is A, this is B, this is the intersection. Now when I say P of A given B, I am basically looking at universe only having B element, right? And then I am asking what's the chance that A happens. So that is going to be this probability. So that is the P of B happens with chance B, that is like the ratio that comes in denominator, and whatever A and B happening is P of A and B. So this is how the formula comes. I hope this is clear to everybody.